right, welcome to class, everybody. I hope you guys are having a good day. So today we're going to cover section 2.2. So when you open up your homework in XYZ, you'll be doing section 2.2. And this is all about solving and evaluating formulas. So I can't remember if I said this last class or not. So if I didn't, here it is again. So the way that I'm going to do the lectures is at the beginning of class, I'm going to do like a little section about the main concepts of that lesson and go through like a couple key examples. And during that time, I'd like to ask that everybody has their laptops closed so that they're focused and able to understand all of the concepts I'm going through. And then after I finish that little introductory section, then I'll let you guys know if you'd like to work on your homework, you can open up your laptops, and everybody can open up their laptops and work on their homework if you want to. Or you can also like go through more examples with me. Today's lesson is relatively easy, so I'll probably just give you guys homework time, and then any questions you have, you can ask me during that homework time. But at the beginning of class, we'll just have like a laptop closed part of class so that you like, I don't have to repeat myself for something I said, but someone didn't get. So with that, let's jump into our lesson. So our lesson is about solving and evaluating formulas. So first of all, let's just quickly review what a formula is. So this is a very common formula. We have speed equals distance divided by time. So say, for example, you drove like 300 miles in 6 hours or something. If you do 300 miles divided by 6 hours, that tells you you're going 50 miles an hour. So this is a formula that's used a lot in everyday life. And it's often written like this because we don't want to have to write out all the words. So we use the variable S to represent speed, D for distance, and T for time. So you could write the formula like this, but you could also write it like this. You could say distance equals speed times time. Like in the example I just did, if you were going 50 miles an hour for 6 hours, that would be a distance of 300 miles. So formulas can be written in lots of different ways. And we can convert this formula into this form by doing the things that we talked about yesterday. So we learned yesterday that if you multiply both sides of an equation by something, then the equation will still stay this like true, I guess you could say. So if I multiplied both sides of this equation by t, I could cancel out these t's, which would give me distance equals time times speed, which is this formula here. So one of the things we'll be working on in this homework assignment is converting formulas so that they're solved for different variables. Because this form of the equation would be really useful if you were trying to find the speed and you had the distance and the time, because it just straightforwardly tells you what you need to do. This one, though, would be more useful if you had the speed and time and wanted to find the distance. So as an example of this, we might have this formula, which, does anybody know what this formula is for? Yeah. Yep. So it's the perimeter of a rectangle, because like if you're trying to find the distance around the outside of the rectangle, you do the width of the rectangle twice, and then the length of the width of the rectangle twice, and add those all together. But you don't have to know what the formula means. So like in your homework, you're going to have a whole bunch of formulas, and all of them are common formulas that are used in science applications or various things. But you don't have to know what the formula means in order to be able to solve it. So the way that we solve the formula for a specific variable, so in this case, we want to solve for W, is we treat the W as a variable, and we treat all of the other variables almost as if they were numbers. So the way I like to think about this is literally thinking about them as if they were numbers. So I'm just going to make up numbers for P and L. So let's say the perimeter is 100, and let's make the length maybe be, I don't know, 5 or something like that. So I just randomly made these numbers up. This is not the problem they asked me to solve, but it's going to help me think about how to solve the problem they did ask. So if I was solving this, where I'm thinking about P and L as just being numbers, the way I would solve it is I would start by saying, well, 2 times 5 is 10. And then to get the W by itself, I would subtract 10 on both sides, which gives me 90 equals 2W. And then I would divide by 2, which would tell me that W equals 45. But this is only if the perimeter is 100 and the length is 5. The formula is in general for any perimeter and any length. But the process of solving it will be very similar, because my first step, if I look at it, was to do 2 times 5 equals 10. Well, if I look at the formula they gave me, I don't know what L is, so I can't simplify that any further. So I won't do that step. But the next step, where I subtract 10 from both sides, I will do that. And I'll subtract 2L from both sides of the equation, because 2L is what that, in this made up example I did, that's what the 10 is representing. Does that make sense? I'm kind of like using this as an analogy to help me solve this problem. So when I do that, P minus 2L, since I don't know what P is and I also don't know what L is, I can't really simplify that. So I'll just write it as an expression, and I get P minus 2L equals 2W. Then I'll divide both sides by 2, which gives me the formula that W equals P minus 2L divided by 2. So you could just type that answer into your homework system, but you could also, if you wanted to, division distributes just like multiplication does. So if you wanted to, you could do P divided by 2 and negative 2L divided by 2, which would give you P halves minus L. Because P divided by 2 is P halves, negative 2L divided by 2, 2 divided by 2 is 1, so you just get negative L. So either one of those answers would be acceptable, because in both cases, you've solved for W. So I would say those types of problems are the harder ones on your homework. There's some other ones that, in my opinion, are easier than that. So let's do a quick check-in on a scale of 1 to 5. How do you guys feel about this problem and how to solve for it? Okay, and I can go through, maybe let's go through one more example before I move on to the other type of problems. So on this one, this formula is the conversion formula for converting Fahrenheit to Celsius. So F is the temperature in Fahrenheit, C is the temperature in Celsius. And if I wanted to solve for C, I'm going to think of C as being a variable, and I'm going to think of, or kind of treat F as if it were a number. So if you want to, you could actually think about it and be like, oh, well, let's say F is 100 or something like that. And you could solve the equation and kind of do like a parallel equation like I did on the last problem. But if we think of F as a number and we're trying to find out what C is, what would our first step be? Yeah. Perfect. Yep. So I'll subtract 32 from both sides. And I don't know what F is. And so I'll just leave it as F minus 32. And whatever F is, F minus 32 will end up being a number. So like if F was 100, this would end up being like 68. But I'm just thinking of that as being a number. And then I have 9/5 C. And I don't think we talked about this in yesterday's class. But if you ever have multiplication by a fraction and that's what you're trying to get rid of, you could divide by this fraction, but dividing by a fraction is done by multiplying by the reciprocal. So I think it's easier to just multiply both sides by the reciprocal. So we multiply this, and when I do that, 9 divided by 9 is 1, so those cancel out. 5 divided by 5 is 1, so those cancel out. And we get that the Celsius temperature equals 5/9 times F minus 32. So you could leave it like that, or if you wanted to, you could also distribute this fraction, and your homework system should accept it either way. If it were me, I'd probably leave it like this, because like, if you needed to use it, it would be more useful. Like say, oh, the Fahrenheit temperature is, I don't know, like 80 degrees. And then you could plug that in, subtract 32, and then multiply by the fraction. But mathematically, you could distribute it and it would still be the same type of problem. So you'll have some problems like that where you're asked to solve a formula for a certain variable. And then you'll have some problems where you're asked to evaluate formulas. So what we just did was solving a formula where we got a variable by itself. Evaluating is when you are given certain values for different parts of the formula, and then you find the variable from there. So in my opinion, this is easier than what we just did, because an example of this would be like find L when W equals 4 and P equals 12. Well, if P equals 12, I can just replace the P with a 12. And I'm trying to find W, so I'll leave that. And then L, oh no, sorry, I miscalculated that. I know that W is 4 and I'm trying to find L. So I'd have 2 times 4 plus 2L. And so once you've substituted the values they gave you, which that's the evaluating piece, then you just solve it like what we did yesterday in class. So in this case, you do 12 equals 8 plus 2L, subtract 8 from both sides. That would give you 4 equals 2L. And then you would divide both sides by 2. So you get 2 equals L, and that would be your answer. So when you're asked to like evaluate and then solve, your answer is going to end up being like a number, because essentially it's giving you a specific rectangle you're talking about. So like if this is the perimeter of a rectangle, we're talking about a specific rectangle where the width is 4 and the perimeter is 12. When we problem back here, we were trying to find a general formula that we could use to find the width if we knew the perimeter and the length. So in my opinion, these types of problems with evaluation are much easier because they're similar to what you guys did yesterday. So the last thing I want to talk about is word problems. So in this class, if you have a word problem in an assignment, it's related to the unit that it's in. So in this case, where it's the point of the word problem is going to be related to using formulas. So regardless of what the topic is, though, the way you solve word problems is first by identifying the things you know, and then identifying what you need. Because the thing that makes word problems, I guess, more difficult than just a basic equation is that it's not always clear unless you know how to kind of like break them down, like what you're supposed to do. So in this case, as I read through it, I'm going to highlight the things that I know and then highlight the things I need. So this word problem says, if you can measure the area that the tires on your car contact the ground and know the air pressure in the tire, then you can estimate the weight of your car with the following formula. So the formula is something they gave me. So that's something I know. Then it says where W is the vehicle's weight in tons. So that's an important thing to know, that W in this formula is representing weight. Then A is the average tire contact area. P is the air pressure in the tires. And N is the number of tires. Then it says, what is the approximate weight of a car? So that's the thing I'm looking for. If the average tire contact area is a rectangle, 7 by 5 inches, and if the air pressure in the tires is 35 PSI. So I underlined this in red because this is the thing I'm looking for. So I say, okay, well, what do I know about this thing I'm looking for? Well, I know that the weight of a car can be calculated with this formula because W is talking about a vehicle's weight. So I'm going to say, okay, well, I'm looking for W then. And in order to find W, I need to know what all of the parts of the formula are. So I would say, okay, well, A, according to this piece of information, is the average tire contact area. So I'd say, okay, well, if I look at this situation they gave to me, it looks like they didn't tell me what the area is, specifically like what the number was, but they did tell me that the contact area was a rectangle that's 7 inches by 5 inches. So what would the area of a rectangle that's 7 by 5 inches be? Yeah, 35 square inches. So that's the area, because rectangles, you can do length times width to find the area. So that takes care of the A part. Then P is the, what did they say? Air pressure in the tires. And they told me here that that was 35. So those happen to be the same numbers, but this 35 comes from the area of a 7x5 rectangle. This 35 comes from the air pressure. And then what does N represent? Number of tires. Now, they didn't tell me what the number of tires on the car was, but how many tires do cars usually have? 4. So that's a piece of information that you just kind of need to know, but hopefully everyone knows that cars have 4 tires. I know trucks sometimes have more than that, but cars usually just have 4. Oh, okay. And then we divide by 2,000 because that's the formula here. So we have the area, the pressure, and the number of tires. And so to finish this, you would just plug that in your calculator, figure out what that is. So those are all the basic concepts you need to be able to do your homework. So you guys can open up your laptops if you want to and start working on the homework. And if you guys have any questions, I'm happy to help with them. Okay, awesome. So on this one, we have several different units that we're working with. So we have like 3 hours, 30 miles upstream. So we've got hours and miles. And we've got a speed measurement of 13 miles per hour. And then we're also asked to find a speed. So it seems like the most commonly used unit is speed. So we want to convert the 3 hours and the 30 minutes into a speed, because it took us 3 hours to go 30 miles upstream. And so I could write that and I could say, well, my upstream speed is going to equal 30 miles divided by 3 hours, which is 10 miles per hour. And then they told me already, but I'll write it here as well, that my still water speed is 13 miles per hour. And then they're asking, what is the speed of the current? So like if we envision this, like in still water, if there was no current at all, the boat would be going 13 miles an hour. However, when it's going upstream and the current is pushing against it, it goes slower, even though the motor of the boat is still pushing it forward just as fast, you could say. The amount that it actually moves when you compare it to the shoreline is only 10 miles an hour. And so the speed of the current in this case is going to be 3 miles an hour, because the current is taking 3 miles an hour away from the still water speed. Does that make sense? Because it's like, if you're going upstream, you have your still water speed, but then the current is being subtracted. So you could write it as an equation, and you could say like still water speed minus the current. And the reason it's minusing it is because the current is working against it. That equals this upstream speed. Does that make sense? And so like if we put in our numbers, we would get 13 minus the current speed equals 10. And that's how I know that the current speed is 3. And some of you guys might have different numbers. So one of the things about our homework system is like it creates random numbers. So some of you guys might have like 4 hours, or like your numbers might be different, but the process of solving it will be similar. Yeah, thanks for asking. Did you say this was number 13? I'll just label it for 15.
In parentheses 14 minus C.
C. 32. And this is number 6. Okay, I'm going to go over number 6 if you guys want help with this one. So the formula is D equals R minus C in parentheses times T. And we want to find C if D equals 32. So we'd have 32 equals, and then R is 14. So we have 14 minus C times T, which is 4. So there's two ways you can do this. So remember how we talked about when you solve an equation, how you go backwards of order of operations? So essentially, like if we knew what C was, the way we would simplify this is we would do 14 minus it, and then we would multiply by 4. So if you wanted to, you could divide by 4 because you're like working backwards of order of operations, and then subtract 14 and then get rid of the negative sign. The way I would do it though, probably is I would simplify the parentheses. So I would do 4 times 14, which is 56, I think. You might want to check me on your calculator on that because I'm not sure if it is 56. Okay, cool. So you can write it like this, and then you can solve, like this looks a little bit more familiar to what you have solved in the past. So you could subtract 56 from both sides, and that gives negative 24, I think, equals negative 4C. And then you divide both sides by a negative 4 to get rid of the negative 4, and that tells you C equals 6. Does that answer your question on that? Okay, cool. I thought I saw another hand over here. Yeah. 13? Yeah. What does your number 13 say? Because everybody has different numbers. This one. And then what are you asked to do? Okay. So since we're solving for y, we're going to treat y like a variable, but we're going to treat x as if it were a number. So if x was a number, like let's say it was like 5 or something, and you have 5/3 plus y over 2 equals 1, you could subtract, you know, like the 5/3, or in this case, x/3 from both sides. But it'd be a lot easier if you didn't have any fractions. So this is the place where you would use the trick that we learned last class, where you multiply both sides of the equation by the common denominator to make it so you don't have any fractions at all. And so in this case, the common denominator would be 6. So I'll multiply both sides by 6, and 6 divided by 3 is 2. 2 times x is 2x. So I'd get 2x there. And then 6 divided by 2 is 3. 3 times y is 3y. And then 1 times 6 is just 6. And again, we're trying to solve for y. So we're treating x as if it's a number, which means 2x is just a number. So I kind of think about this as being just like a single number. And I say, okay, well, I would want to get rid of that before dividing by 3. So I'm going to subtract 2x from both sides. And that gives 3y equals 6 minus 2x. Then to get y by itself, I divide by 3. And I get y equals, you could either just write it like this, or you could distribute the division by 3 and do 6 divided by 3 is 2. And negative 2x divided by 3 is negative 2/3 x. So you could write it in this form, or you could write it like this, and either one would be right. Yeah. You're like, all done with the homework? Sure. Yep. Yeah, and I think with the last 10 minutes, I'm gonna go over a couple like trickier problems that may show up on your homework, because like the homework shuffles through questions, so not all of you will get this question, but I want to talk about how to solve this. So if you were asked to solve this formula for x, this one's a little bit more complicated because we have 2 x's. So if you imagine how you would solve this if like, because we're thinking of a and b as being numbers. So like if you had 7x minus 3 equals, I don't know, like 4x plus 5, the way you would solve this is you would get rid of one of these, right? And so you're going to do the same thing here, where we're going to say, okay, well, let's say I want to get rid of bx. The only issue is that if we subtracted 4x, like in my made up example, we could figure out what 7x's minus 4x's are. But in this case, we don't know what A and B are. So it's not like we can say, oh, well, A minus B equals this thing. And so what we do instead is we just put it in parentheses and we say, well, whatever A and B are, the number A minus B is how many x's I have. Does that make sense? Another way you can also think about this is you could write it out as AX minus BX minus 3. And since these two terms have an x in common, you can factor the x out. So if you like thinking about it as factoring, you can think about it that way. But I like thinking about it as I have A x's, I'm subtracting B of them. And so whatever number A minus B is, I have that number of x's. But in either case, the goal is to get it so that you just have one x instead of having two x's. And then from there, you just say, okay, well, I have this number times x minus 3 equals 5. To get x by itself, I'd add 3 to both sides, which tells me A minus B times x equals 8. And then whatever this number is, if I want to get x by itself, I'm going to divide both sides by it. So I divide both sides by A minus B, and that would give me x equals 8 over A minus B. So that's how you could do that one. And this one is very similar. Oh, not that one, sorry. This one is very similar because in this one, we're trying to find P, but there's two P's. And so before we can solve for P, we need to make it so there's just a single P. So the way that I would think about it is I would say, okay, well, I have one P right here because 1 times P is still just P. So I'll think about it as being 1P. And then I don't know what R and T are, but I'm thinking about them as if they're just numbers. So like if R was, I don't know, like 7 and T was 8, RT would be 56. Or if R was 1 and T was 5, RT would be 5. Like whatever R and T are, when you multiply them together, you're going to get another number. So I'm going to think about RT as being a number, but I just don't know what it is. So both of those multiplied together, I'm going to think about it as a single number. And I say, okay, well, I have 1P and then I have RT, whatever that number is, I have that many P's. So if I have 1P plus RT P's, then that's going to be 1 plus RT, whatever that number is, times P. And again, you can also think about this as factoring. So because they both have a P in common, you can pull the P out. So it just kind of depends on which way you think is easiest to think about it. And that equals A, and I'm trying to get P by itself. So whatever this number 1 plus RT is, I'm going to divide by that number. And that tells me that P equals A over 1 plus RT. And that would be my solve formula. If you get one like this, where you're asked to solve for Y, like essentially you're going to think of B and X as being numbers, but that also means you're going to think about this as being a single number, because whatever X is, if you subtract 5, you just get another number. So if you say, okay, well, if I have a variable minus something divided by a number, the way that you would solve this is you would multiply by that number. So let me rewrite this problem real quick. So we would multiply both sides by the number x minus 5, because when I multiply by the number x minus 5, this and this will cancel out. And that gives me y minus b equals, on this side, I could do m times x is mx, m times negative 5 is negative 5m. And then to get y all the way by itself, I would add b to both sides. And so y equals mx minus 5m plus b. And I would guess that your homework system would probably accept it if you left it in parentheses and then you had a plus b at the end. Yeah. Oh, it's not on this homework?
No, it's not. It's not. Like,
Oh, okay. Yeah, go ahead. Which one is it?
It says the.
Oh, yeah. So I actually just went over that a little bit earlier. So I'll show you on my iPad on that. So we have like 5 more minutes, and I was wondering if I could get your guys' feedback. Do you guys feel like it was helpful for you to have that homework time in class? Yeah. Okay. So I think I'll keep on doing it like that. The one tweak I'll make just so that like I want to make sure that you guys are getting plenty of examples because I know some people like they would rather get a lot of examples in class and then do their homework on their own time to give them more possibilities to study. So what I'm going to do moving forward is we'll still do the same structure, but instead of having it just be silent, I'm going to choose some of the homework problems that I think are the hardest or the most challenging, and I'll focus on those and go through them. And you're welcome to follow along with me, or you can work on your homework and kind of tune me out. So we'll just make that slight modification in the future, but thank you guys, and I hope you have a good day. Okay, so let me go back to the one that we solved here.
Yeah.
So her numbers were slightly different than yours, but it's basically like the idea of like, if you're going 3 hours, or if it takes 3 hours to go 30 miles upstream, you have still water speed of this, and you're trying to find the current, right? So these are the things, you know, this is what you're trying to find. So one of the things that can be helpful with word problems is to look at the units. So like this is a speed unit, this is a speed.
Yeah.
And we can convert this into a speed. And we can say the upstream speed is 10 miles an hour because 30 divided by 3 is 10. And then you say, okay, well, the still water speed, because the current is pushing backwards against the still water speed, you would subtract the current speed to get the upstream speed.
Yeah.
And so that tells us that 13 miles an hour minus whatever speed the river is flowing at has to equal this 10 miles an hour of the upstream speed. And then that just means C is 3. So your numbers will be different.
So how many miles? 10.
Yeah, so what's your upstream speed?
Upstream is 10 miles per hour.
Well, no, just 10 miles. So it
10
takes
miles.
2 hours to go 10 miles.
10
So how
miles.
fast is it going upstream? 5 miles an hour. So if going upstream, it's 5 miles an hour. But if there wasn't the current pushing against it, it'd be going 8 miles an hour. How much is the current pushing against it? 3. Yeah.
Put this in the denominator.
So put parentheses around the L and the W, and that will fix it.